Welcome to Real Civil YouTube channel. In this video, I am going to show you how to model a single degree of freedom system problem in ETABS software. And finally, we are going to compare the results also. That is the time period. So here the problem is given and we have solved this problem. So I am not going to discuss this problem manual method. I am going to show you how to model this in ETABS software. Okay. So here in ETAB, go to new model. Then use built-in setting metric Indian IS 800 2007 IS 456 2000. Here we'll select the custom grid spacing. Click on edit. So if you see our problem, this is 4 meter, height is 5 meter. Okay. So here we also require this center point. So we'll mark a grid line of 2 meter also. So 2 meter, 4 meter, and keep the last one 0, doesn't matter. And in Y grid data we are not going to change anything because we are going to analyze this in 2D. And then here keep the number of story 1. The frame height is 5 meter, so make sure typical story, even bottom story you can keep it as a 5 meter. Now this is the plan view, but we want to work in the elevation. So go to the elevation and select one here and click on apply. Okay. Now we are going to model this frame. Okay. So the first we are going to define the material properties. E is equal to 22.4 GPa. So first go to define material properties, add new material. Here concrete. Here you can select any grade. Okay, because we are going to change the properties. So weight per unit volume, that should be 0 because the frame we are going to analyze is massless in this problem. So that's why we have to keep this as a 0. And modulus of elasticity is given 22.4 GPa. So we'll change this 22400 because this unit is in MPa. So click on OK. Now again we are defining the material property of steel, that is rebar. Click on OK. Again we want to make it massless, so 0, and here 22400 MPa. So we have converted that value GPa to MPa. Okay. Now we have defined the material. For the section properties, beam section is 230 by 230, column is 230 by 300. Okay. So go to define section properties, frame section. Here go to add new property, rectangle. Now here you have to go with M20. Before that give the name, first column 230 by 300, depth is 300 and width is 230. Then go to modify show rebar. Here make sure the option is column, and then the longitudinal bar and confinement bar. Here we have to select the material that we have defined. So that is steel material, you have to select FY415. Click on OK. Click on OK. Your column is defined. Now beam is 230 by 230. So we will define the beam. Again rectangular cross section, beam 230 by 230. M20 grade. Depth is 230. Width is 230. Now we want this member to act as a beam. That's why we will select the beam. Select this reinforcement 415. Remaining, keep it as it is. Click on OK. Now defining part is over. Now we will draw this frame. Okay. So go to draw option. Here draw beam column. Now here in property, select the column and draw this column. Okay. Right click. Then again. Okay. Now here you have to select the beam and we'll draw this beam here. Okay. Escape. The modeling part is over for the frame modeling. Now we have to assign this lumped mass of 450 kilonewton at the center. Okay. So if you see, there is no any node here. Okay. If I try to select it, this is just the grid line. Okay. So go to draw joint objects, and here select this point. Okay. Now we will assign here 450 kilonewton. So we have converted this 450 kilonewton into kg, that is 45871.55. So go to first select this joint, go to joint, assign joint, additional mass, and in direction xy, because we want it in x direction to be excited. So here 45871.55 kg. Make sure the unit is kg. Yes. Click on apply. Click on OK. Now in the problem, the supports are fixed. Okay. So select these two joints. Go to assign joints, restraints, and here click on this fast restraint first option. Apply. Okay. Now you can see your supports are fixed now. Okay. Now the modeling part is over. We'll go to analyze, and here the option is set active degrees of freedom. So here we want the analysis to be in the 2D, and that is in the XZ plane. Okay. There is no any component in Y direction. So make sure it is XZ and click on OK. Now again go to analyze, set load cases to run. Here we don't want to run the dead load case. We don't want to run the live load case. So click here and make the action do not run. We will only run the modal case, that is pre-vibration. And now click here, run now. We have to save this. So give any name to this. Now the software will analyze this frame. Now here you can see in the right window, I will make this elevation view. Now here you can see the time period is 1.17. Manually, I have calculated the time period is 0.90. Okay. So what is the difference? So the difference is because I will show you here. Here you can see the frame, that is beam is bent. Okay. And in this problem, we assume that the frame is or the beam is infinitely rigid. That means beam is not going to bend. Okay. I will model the same also. But first observe this mode shift. So click on start animation. Now you can see here the vibration of the frame, and you can see the beam is deflecting. Okay, so that's why there is a difference. So let's modify our frame. So before that, unlock the model. Now select this joints, go to assign joints, restraints, and first make it null, and then rotation about y. We don't want the beam to deflect in y direction. Okay, so there will be restraint, and click on apply, click on OK. Now go to analyze and run this case. Now we will see what is the time period. Now here you can see the time period is 0.90. Manually also we got 0.90. Okay, so that is how you can model this problem in ETABS software. Now if I start the animation, you can see now beams are not going to deflect, only columns are getting deflected. So this is how you can model single degree of freedom system. In dynamics, we assume that beams and slabs are rigid, so they will move without bending, like this case. So that's why our time period is matching. If you consider beam to be bending here, then here instead of 12a upon L cube, for the stiffness you have to consider 3a upon L cube. Then you can got the that time period. So this is how you can model. So if you have any doubt, you can ask me. Thank you so much for watching the video. Please like, share, subscribe the channel.